Chapter 4.3 Day 2 Dividing Polynomials. We are going to discuss today the remainder theorem of polynomial. If a polynomial fx is divided by x minus k or any factor x minus 2, x plus 2 or something like that, then remainder is r equals f of k. It means the remainder will be function value at this number, this k. So for example, if this is x minus 2, then remainder would be f of 2. The remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. So to evaluate f of x, when x equals k, divide fx by x minus k, the remainder will be f of k. Again, using or evaluating the function at x value or any x value, you can find the remainder, and that will be f of k or f of 2, f of 3. So normally when you find f of 2, you just plug it in x as 2 in the whole equation. And now we learned that we can also find that f of 2 using synthetic division by following remainder theorem. Now we are going to do example number 4. We are going to evaluating a polynomial f of x at x equals -4. We are going to use synthetic division to evaluate. So we are not actually substituting this x value to x places, but rather than that, we are using the synthetic division. So if x equals -4 and we are going to find out the synthetic division, we make this half rectangle and we write the x value -4 here. Remember, if x equals -4, we can also write this into this form, x plus 4. Just remember, we are going to add 4 on both sides, and in this form, this becomes a factor type of form. So which means that you can write either x plus 4 or x equals -4. But in the synthetic division, when we divide, we are going to use the -4 x value, not the factor. Now on top of this, we are going to write the coefficient, that is, the coefficients are 5, -1, 13, and 29. So we are going to write it over here, -1, 13, and 29. You bring down the 5 as it is, and you're going to multiply with -4, so you get here is -20. At -1 and -20, you're going to get -21, and then you're going to again multiply -21 with -4, and that's going to give you 84. Now we are going to add 13 and 84, that's 97. Multiply with -4 again, you're going to get -388, and then the remainder you're going to get is -359. So the value of the function at x equals -4 is -359. Remember, we did not plug the x value, x equals -4, into x places, but rather than that, we use a synthetic division to evaluate f of -4. Now I'm going to use the substitution to find the value of the function at x equals -4. So instead of using synthetic division, now we are going to plug it into the function fx equals 5x cubed minus x squared plus 13x plus 29. And I'm going to use x equals -4. We are using the substitution method to evaluate this time. So see if we can get the same answer as the previous example, -359, or not. So we're going to plug it in x equals -4, but instead of using the synthetic division, we are using substitution this time. So negative 4 to the power 3 is negative 64 minus 16 minus 52 plus 29. And here we got is negative 320 minus 16 minus 52 plus 29. And now you can add these two. You get here is negative 336. And now you're going to combine these two. You get here is negative 23, and your answer is negative 359. And you can see that using the synthetic division, we got the f of negative 4 as negative 359, and same answer we got when we plug it in or substitute negative 4 into the function. So either you use synthetic division to evaluate the function value at x equals negative 4, or you use substitution, you're going to get the same answer. Next, we are going to do question number 5, you try problem, and we are going to use synthetic division to solve for f of 5. And first, we are going to write a half rectangle and use 5 as x value. Now we are going to write down the coefficient of the function. The coefficients are 4, negative 10, and negative 21. So we are going to write over here. Bring down the 4 as it is. You multiply it by 5 and write it underneath here. Add them together. You got is 10. So 20 minus 10 is 10. 10 times 5 is 50. You write it underneath in the next one. And then the remainder is going to be 29. So f of 5 is going to be 29. Now we can use the substitution method. So here I'm going to use substitution to see whether we get f of 5 equals 29. So 4 times 5 square minus 10 times 5 minus 21. So that's going to be 4 times 25 minus 50 minus 21. So that's 100 minus 50 minus 21. 100 minus 50 is 50. 50 minus 21 is 29. So whether you use the synthetic division or you use a substitution, you got the f of 5. Evaluating is same. So f of 5 in both cases came out 29. Now we are going to do question number 6, and we are going to complete the equation first. So first of all, f of x should be 5x to the 4 plus 2x cubed. X square missing, so we need to plug it in 0 for x square. Otherwise, our answer will not be correct. We're going to use the value for x, and that's going to be 2. Again, if you write it in a factor form, that's going to be x minus 2, the opposite sign. Write a L or a half rectangle for synthetic division. You're using x equals 2. And then the coefficient are going to be 5, 2, 0, negative 20, and 6. Apply the synthetic division. Bring down the 5 as it is. Multiply with 2, and you're going to get 10. Add them. You're going to get 12. 12 times 2 would be 24. And 24 down here. 24 times 2 would be 48, and that's going to be 28 when you add. 28 times 2 would be 56, and when you add them, you're going to get the remainder as 50. So f of 2 is 50 when we use the synthetic division. So now I'm going to check the answer f of 2 by using substitution. So I'm going to use 2 and plug it into the function for x. So I'm going to use 2 and solve it. 5 times 16 plus 2 times 8 minus 40 minus 6. This becomes 80 plus 16 minus 40 minus 6. This becomes 96 minus 46, and you're going to get answer as 50. So either you use the synthetic division or substitution. The value of f of 2 is same.